Welcome to Summarized Science, where we break down complex research into simple terms. Today, we're talking about the most powerful particles in the universe. Scientists call them ultra-high-energy cosmic rays, and they hit our atmosphere with more energy than a major league fastball. The biggest problem is, we still don't know where they come from. To solve this mystery, an international team is building a massive new observatory called GRAND. It's not a typical telescope with lenses. Instead, it's a giant network of radio antennas designed to listen for the faint radio flashes these particles create when they strike the air. Before building the full array, which will eventually cover an area the size of a small country, they have to test the technology. That's where these prototype arrays come in. This paper focuses on two main ones, GRAND Proto 300 in the Gobi Desert in China and GRANDAuger in Argentina. These test sites allow them to see how the equipment holds up in very different and harsh environments. Each site is dotted with these self-contained detection units, or DUs. Think of each one as a smart antenna, complete with a solar panel for power and its own little computer to process what it hears. They're designed to sit out in the middle of nowhere and run completely on their own. The biggest challenge for these antennas is that the Earth is incredibly noisy in radio frequencies. They have to pick out a nanosecond-long whisper from a cosmic ray amidst a constant roar of radio signals from things we create. This chart from the Argentina site shows just how much interference there is. You can see distinct spikes from sources like FM radio, TV carriers, and even communications from planes and satellites. This is what the data looks like over several days, showing the radio power at different frequencies over time. The bright vertical lines are that constant radio interference we just saw. The white gaps are periods where the detectors had to hibernate, either because of extreme heat or not enough sunlight to charge the batteries. After running these prototypes for about 2 years, the team has made a crucial discovery. Even though the hardware is slightly different at each site, and the Chinese desert site is much quieter than the Argentinian one, the performance of the detectors is remarkably consistent. So, let's recap the important points. The GRAND experiment is hunting for the origin of the most powerful particles in the universe by listening for their radio signals. The prototype arrays have proven that the custom-built hardware is robust and can operate autonomously in difficult environments. And most importantly, they've shown that the detection units perform consistently well, even when faced with very different levels of background radio noise. This is a foundational scientific result for the project. It confirms that a future, giant network of these antennas spread across the globe can work together and have their data combined reliably. This successful first step paves the way for the next stages of GRAND, bringing us one step closer to solving a huge cosmic mystery.